Alright, so we have to review some vocab first, such as polynomial, like terms, monomial, binomials. So we're going to do a lot of writing, so excuse my terrible handwriting, please. Alright, so a polynomial is an algebraic expression. So an algebraic expression, remember, an expression is something without an equal sign. So an algebraic expression with one or more terms. With one or more terms. So hopefully you're thinking, what's a term? Right? So that's our next vocabulary word. So a term is a number, a variable, or the product of numbers and variables. Or the product of numbers and variables. So example of a term would be something like 9 or x cubed, or both 9x cubed. So those are each terms separately. Okay? And for the most part, terms are separated by addition or subtraction signs. Okay? So they're separated by addition or subtraction signs. Okay? So again, that would be something like if we had 4x squared plus 3. So 4x squared is a term and 3 is a term. Not the whole thing. The whole thing's an expression. But 4x squared is a term and 3 is a term. Okay, so let's talk about like terms. So like terms are, as they say, exactly alike. So they're exactly alike. So what I mean by that is that they're the same variable raised to the same power. So it's the same variable. So something like x and x. So the same variable raised to the same power. So like x cubed and x cubed, or x squared and x squared. But x cubed is not a like term to x squared because they're not the same power. Okay? The kicker here, or the thing that's important, is that the numerical coefficients can be different. Okay, so the numerical coefficients can be different. The other thing to go back to before we talk about numerical coefficients are that constants are like terms. Okay, so constants are like terms. Anything that's the same power to the same number, the same variable to the same number are like terms, but it doesn't matter what that number is out front. So it could be like 3x squared and 4x squared. As long as it's both x to the second power, they're still like terms. Okay? So you may be trying to refresh your brain on what is a constant. So it's a number acting alone. So it's a number acting alone. So I'm kind of going to go back a little bit. So a constant, looking up at this term thing, the constant in that would be that plus 3. It's a single number. It's a constant, okay? Then a numerical coefficient is the number times a variable. So it's a number times a variable. Okay, so that would look like the 4 in front of the x squared. That's our numerical coefficient. So make sure you see the difference there. So let's talk about monomials. Think about what the root word of mono means. So in case you don't know what mono means as a root term, it means 1. Okay, so that's why it's a polynomial with one term. Okay, think about what the root word bi means. Bi. So think about a bicycle. Okay, so that root word means 2. So that means 2 of something. Okay, so that means a polynomial with 2 terms. Okay, so again, examples of that would be, an example of a monomial would just be 9, which is also a constant. Or it could be something like 4x cubed y second z to the 11th h to the 4th. Okay, that's all one term. So that's a monomial. Whereas a binomial is a polynomial with 2 terms. So again, an example would be like 4x squared plus 3. So that's 2 terms separated between a plus sign or a minus sign. Okay? Or something like 3 minus 7. Okay, those are technically binomials. Okay, because they're 2 terms separated by that addition or subtraction sign. Okay, so now we've got the vocabulary out of the way. Let's get to the actual math, all right? So for these examples, it says simplify. What that really means is that's just telling us to combine our like terms. So that's just saying combine your like terms. Okay, so what I would do is I would highlight all of my like terms. So anything with the same power and the same variable. So I'm going to highlight all of my x squareds, all of my x's, and I make sure that I highlight the operation with them as well. So that way when I write it all out, I can get a clear identification of them. So combining like terms, we've identified all of our like numbers. So the things with the same variable to the same power. Okay, remember constants are like terms. Okay, so now I'm just going to combine them. So I have x squared plus 2x squared. And I have negative 9x plus x. And then a plus 3 minus 4. And now I just simply add or subtract there. Okay, so you should get 3x squared minus 8x minus 1. Okay, so again, we identified what our like terms were, then we simply added or subtracted them. So let's look at example 2. Example 1 was pretty easy, straightforward, because it was a plus sign, because I was adding both of those up. But this time, what do you notice here? We're subtracting. Okay, so when we're subtracting something with the parentheses afterwards, there's an implied 1 in front of here that we have to distribute. So the thing here with subtraction is that you have to distribute that subtraction sign first. Or really distribute that negative 1. Okay, so when you distribute that, then it makes it a plus negative x squared minus 2. And this first binomial stays as it is. Okay, so again, because there was a subtraction sign there, there's a 1 in front of all of these parentheses. There's a coefficient there that's always a 1, and that gets distributed in to both of those. Okay, and now we just simply combine our like terms. So 4 minus 1 is 3x squared, and then minus 9 minus 2 is negative 11. Okay, so I want you to pause and work on example number 4. Okay, so hopefully for number 3, you got 11x squared plus y squared. Okay, so I don't want to spend time on that. Let's look at example 4. So it says the difference of two polynomial expressions is shown below. It's got all that stuff. We have to find what the value of w is. So there's a w here that we have to figure out. Okay, and it gives us what the answer is. So somehow this expression and this expression equals this last expression here. So what I'm going to do, well, you could do this two ways. You could either plug in all these values for w and see what works. Or what I'm going to do is combine my like terms first, okay? See what we really need to do to this w before I do anything, okay? So again, there's that implied 1 there that we have to distribute. So I'm going to leave this first polynomial as 2x squared plus wx minus 4. Distribute that 1 to everything in the parentheses. Minus x squared minus 5x minus 6. Okay, now I'm going to combine my like terms. X squared wx plus x minus 4 minus 6. Okay, so negative 2x minus x is negative 3x squared. All right, so that's part of our answer. Now we have a plus wx minus 5x. I can't really do anything to these guys yet because I don't know what w is equal to. And then I have a minus 4 and a minus 6, which is a minus 10, which is also part of my answer. So my answer is only a binomial. But if I simplify this right here, I would get a trinomial. So that tells me that these two terms in this middle have to cancel out or have to be equal to 0. So we would, since it has to be equal to 0, we would look at w plus what? Sorry, w minus 5 has to be equal to 0. So between A, B, C, and D, you can either start plugging them in, or I know 5 minus 5 is equal to 0. So then w has to be equal to 5 because we want 0 here because they cancel out. Okay, so let's look at example 5. Okay, so looking at example 5, pause. This might make you motion sick for a second, so give me a moment. Okay, let's move that out of the way. Okie dokie. So now we have no real signs here, right? But there's these two things right next to each other. So if there's a number or a term in front of the parentheses, that tells us that we should distribute that in. So our first step here is to distribute. Okay, so we're going to distribute. And what else we're going to use is we're going to have to use our exponent rules. So we want to use exponent rules. Okay, so we have to use those exponent rules. And when we do that, when we get 2x times 4x squared, we should get negative 8x to the third. Remember our exponent rules. If we multiply straight across, That means we add our exponents. Okay, when I do the second number, negative 2x times negative 3x, should be a positive 6x squared. And then the last one, negative 2 times a positive 5, is a negative 10x. Okay, so that's going to be part of, or that's going to be our whole answer because we don't have any like terms to combine. Okay, so then looking at example 6, we're multiplying two binomials. So since we're multiplying two binomials, there's a little acronym for us, and it's called FOIL. So that means we're going to multiply the first numbers, the outer numbers, the inner numbers, and then the last numbers. So that's what FOIL stands for. So see, F-O-I-L, okay. So if you ever see me in the future write FOIL, that's what this means. Okay, and what those really stand for first means we take these first two numbers and we multiply them. So we're going to multiply 4x times x, and that gives us 4x squared. Then we're going to multiply our two outer numbers. Okay, so when we do that, 4x times negative 2 is negative 8x. Then we're going to take our two inner numbers and multiply those. Okay, so we have 3 times x, which is 3x. And then we have our last numbers, the last two numbers. So 3 times negative 2 is negative 6. And then if you can, combine like terms. So combine like terms, if possible. Okay, so combine your like terms. So I don't have any like terms with x squared, so I just leave it as 4x squared. But now I have negative 8x and plus 3x. So that's going to give me negative 5x, and I have no other like terms. So it's just going to be this answer. Okay, so let's look at example number 7 then. Example number 7. So it tells us the length of a rectangle is this. So it's 5x plus 1 units long. The width of the rectangle, the width is 2x plus 5 units long. And we want to find the area, okay? And in case you forget what the area formula is, it's length times width. So what that means is we're going to take and plug it into the formula. So area equals our length, which is our 5x plus 1. So I'm going to put that in parentheses, 5x plus 1, times our width of 2x plus 5, times 2x plus 5. Okay, so now what do you think we're going to do? That's not the answer, okay? So think back to what we just learned when we multiply two binomials together. We can then do FOIL. We can FOIL, okay? So we do the first two numbers. That should give you 10x squared, okay? So I just wanted to start you. So I want you to pause and I want you to FOIL, combine your like terms, and put your answer there. Okay, so I'm not going to walk you through FOILing again. So remember to FOIL. Okay, so pause and do the... Okay, so you should get 10x squared plus 27x plus 5. And we always put units squared. Units squared, okay? Because area was units times units, so that's why it's squared.